Hello, welcome to 3.6, Combining Functions. So addition, subtraction, multiplication, and division of functions would be the following. Let f and g be two functions. The sum f plus g, sum, difference f minus g, product f times g, and quotient f divided by g are four new functions defined as follows. F plus g of x is f of x plus g of x. F minus g of x is f of x minus g of x. F times g of x is f of x times g of x. And f divided by g of x is f of x divided by g of x as long as g of x is not 0, because we cannot divide by 0. The domain of each of these new functions consists of the common elements of the domains of f and g individually, with the added condition that in the quotient function we must omit the elements for which g of x is 0. So we're going to use the information to determine the following. I'm going to find f plus g of negative 1, f minus g of negative 1, f times g of negative 1, and f divided by g of negative 1. So here we're told f of 1 is f of negative 1 is 0, g of negative 1 is 1. So f plus g of negative 1 is f of negative 1 plus g of negative 1 at 0 plus negative 1, which is negative 1. F minus g of negative 1 is f of negative 1 minus g of negative 1 at 0 minus negative 1, which is 1. F times g of negative 1 is f of negative 1 times g of negative 1 at 0 times negative 1, which is 0. And f divided by g of negative 1 is f of negative 1 divided by g of negative 1 at 0 over negative 1, which is 0. For the next one, we have f of x being x plus 5 over 2, g of x being 6x. So if we look at f of negative 1, that's going to be negative 1 plus 5 over 2, 4 over 2, which is 2. And g of negative 1 is going to be 6 times negative 1, which is negative 6. So for a, f plus g of negative 1 is going to be f of negative 1 plus g of negative 1, or 2 plus negative 6, which is negative 4. F minus g of negative 1 is going to be f of negative 1 minus g of negative 1. That's going to be 2 minus negative 6, which is 8. F times g of negative 1 is going to be f of negative 1 times g of negative 1, which is 2 times negative 6, which is negative 12. And the f divided by g of negative 1 is f of negative 1 divided by g of negative 1. That's going to be 2 over negative 6, or negative 1/3. On to the next page. This is the formula and domain for f plus g, and for find the formula and domain for f plus g and f minus g. Okay? F divided by g, excuse me. So for a, f of x plus g of x, well, f plus g I should say, of x is f of x plus g of x. That's x squared minus 1 plus the cube root of x. Now the domain of this, from the x cubed minus 1, domain is all real numbers. And for the cube root, now square root would be different, a fourth root would be different, but cube root, you can still plug in any number. So our domain would be from negative infinity to infinity, or if we want to be technical, it would be x such that x is in the reals. For b, f divided by g of x is going to be x squared minus 1 over, I should say f of x over g of x, which is x squared minus 1 over the cube root of x. Now the domain for this one would be what? Negative infinity up to 0, not including 0, then 0 to infinity. Because 0 makes the denominator 0. Or you can say the domain is x such that x is in the reals and x is not equal to 0. Okay, for the next one I want to scroll the whole thing up. Example 3 says given f of x equals 1 over x squared and g of x equals 2x plus 3, find f plus g of 10, f times g of negative 3, and g over f of negative 6. So this is going to be f of 10 plus g of 10. That's going to be 1 over 10 squared plus 2 times 10 plus 3. That's going to be 1 over 100 plus 23. Or 23 and 1/100th. F times g of negative 3, that's f of negative 3 times g of negative 3. And that's going to be 1 over negative 3 quantity squared times quantity 2 times negative 3 plus 3. So 1 over 9 times negative 6 plus 3. 1 over 9 times negative 3. Negative 3 over 9, which is negative 1/3. G over f of negative 6, that's going to be g of negative 6 over f of negative 6. That's going to be 2 times negative 6 plus 3 over 1 over negative 6 squared. Negative 12 plus 3 times, I'll just do it 1 over 36. That's negative 9 over 1 over 36. Negative 9 times 36 over 1, which is negative 324. So that was combining functions through addition, subtraction, multiplication, division. Now the next topic is combining functions through composition of functions. In the composition of functions, the composition of f and g, denoted f of g like that, consists of all x in the domain of g, for which g of x is in turn in the domain of f of g. So the second one gets plugged into the first. The function f of g is read f composed with g or f of g, and f of g like that could be written as f of g of x. So the idea here is you plug a number in x into the function g. What it produces gets plugged into f. So the range of g is the domain of f. Okay. Now, I probably should have drawn this differently. Let's call this G. Call this F. X goes into G and produces Y. Y then goes into F and produces Z. So A becomes a 1. The 1 becomes an at. This is just some kind of weird function. B becomes a 1. That becomes an at. C becomes a 3. That becomes a pound. D becomes a 4. 4 becomes a whatever. So let's call this just F of G, just to be consistent with the way we started in the previous page. Okay, so example 4 says find f of g of 3 given the following. f of x is the square root of x cubed minus 9. G of x is 1 minus 2x. So what we're looking for is f of g of 3. So our g of 3 is 1 minus 2 times 3. 1 minus 6, which is negative 5. F of 3, well, no. So f of g of 3 is f of negative 5. Because g of 3 is negative 5, that negative 5 goes in place of the g of 3. So we have the square root of negative 5 squared minus 9. It's 25 minus 9. That square root is 16, which is 4. So f of g of 3 equals 4. The next one, f of x equals the square root of 3x over 14. G of x is x to the fourth minus x cubed minus x squared minus x. So our g of 3 is 3 to the fourth minus 3 cubed minus 3 squared minus 3. That's 81 minus 27 minus 9 minus 3. And that's going to be 42. F of g of 3, it's just f of 42, because what g produced, which was 42, now goes in place of the g of 3. That's the square root of 3 times 42 over 14. That's the square root of 3 times 3, square root of 9, which is 3. So f of g of 3 produces 3. Now we're going to find a formula and the domain for f of g and for g of f. Okay, so f of g of x, it's going to be f of what? Well, g of x is x minus 1, f of x is 1 over x. So it's going to be f of x minus 1, so 1 over x minus 1, meaning that this x minus 1 goes in place of this x. And so our domain would be x such that x is in the reals and x is not 1. Another way to do this would be f of g of x would be 1 over g of x, because what does f do to x? It makes it 1 over x. So it's 1 over g of x, and that's also 1 over x minus 1. So two ways to see that process. For g of f of x, that would be g of 1 over x, which is going to be 1 over x minus 1. And in this case, the domain is going to be x such that x is in the reals and x is not 1. Or you can think of this as g of f of x might be 1 over, no, I'm sorry, f of x minus 1. Because what does g do to x? It just subtracts 1 from it. That's 1 over x minus 1. For the next one, we have f of x equals square root of x, g of x equals 2x. So for f of g of x, it's going to be f of 2x, which is the square root of 2x. For this, the domain x such that x is in the reals and x is positive or 0. I should say non-negative because it's a radical. Or you can see this as f of g of x is going to be the square root of g of x, which is the square root of 2x. And then we have g of f of x. It's going to be g of the square root of x, and that's going to be 2 times the square root of x. Again, the domain is the same this time. X in the reals, x is positive. Or you can think of this as g of f of x is g of, no, I should say 2 times f of x, which is 2 root x. Either way of approaching that's fine. On to our last page here. Decomposing functions. That's probably my favorite part of this, is the decomposing functions, because you get to be creative. You get to think, how would I break that up? What do I make the inside function, the outside function? I think a composition of functions like an inside one and an outside one, like we do an f of g of x. G is the inside, f is the outside function. So you get to be creative, and sometimes there are multiple answers to them. So decomposing functions, recognizing a function as a combination of two or more simpler functions. To decompose a function into a composition of simpler functions, identify what the function does to its argument from the inside out. Identify the first thing that is done to the argument, then the second, and so on. Each action describes a less complex function and can be identified as such. So, if we thought of this as f of x equals h of g of x, we have an inside function and an outside function. You might say g of x equals 5x minus 1. So h of g of x is really going to be 2 over g of x, which means your h of x would just be 2 over x. That's one choice. What if you said g of x was just 5x? Then your h of g of x would have been 1 over g of x minus 1. So that means h of x would have to be 1 over x minus 1. So you have two choices there. These go together, these go together. Okay, for the last one from this section. F of x equals the square root of x minus 3 over x squared minus 6x plus 9. That's the square root of x minus 3 over x minus 3 squared. Now I'm tempted to simplify this, but I'm going to probably leave it like that. It might be best just to say g of x equals x minus 3. It's repeated. So your h of x is going to be the square root of x over x squared. And this is where f of x is h of g of x. So your inside function, the g, is that x minus 3. The outside function is going to be the square root of x over x squared. Well, that'll do it for 3.6. Hope you enjoyed that. Some of your questions. Thank you.